Welcome to Lecture 4-1, Measurement and Program Evaluation. In this lecture we'll get an introduction to some general concepts related to measurement and threats to construct validity will be covered in Lectures 4-2 and 4-3. So let's begin. What is measurement all about? It is ultimately about our ability to take abstract constructs and identify them in ways that are concrete, empirical. Identify them in ways that we can see them, feel them, touch them. There are many different ways to actually collect data, including surveys, unstructured interviews, direct observations, and analysis of existing documents. But measurement as a topic is not really about data collection. The two are very related, but they're not the same thing. Measurement is a general topic that cuts across all of these various data collection techniques. We will be discussing data collection techniques such as surveys, interviews, direct observation in this and subsequent chapters. In this lecture, we will focus on the theory and practice of measurement in general. As shown in Figure 4-1, using an open systems model, the biological model that we've been talking about since the early chapters, we use an open systems model that shows outputs, linking constructs, and outcomes as possible candidates for measurement. The chapter, the reading, defines measurement as the process of translating constructs into observables via procedures. These procedures are sometimes referred to as operationalization. We define a set of operations, literally a set of step-by-step procedures, to measure a particular construct. The end result of that is a variable, which we hope, we believe, we try to prove, is related to and is a good indicator of the underlying construct. And again, those constructs might be the outputs of the program, or the linking constructs of our program logic model and design, or the intended outcomes of the program. Figure 4-2 illustrates the place of measurement procedures in the relationship between constructs and variables. It is imperative to remember there are multiple ways to measure any given construct. And in fact, measuring a given construct in multiple ways as part of a single overarching evaluation project is almost always a good idea. The key is to design a measurement procedure, or a set of measurement procedures, that is both valid and reliable. At its simplest, measurement validity means that our resulting variable is a true measure of the underlying concept. As we discussed in the previous chapter, another word for validity is truth, or is it real? You would not, for example, use a tape measure to measure a person's weight. That would not be a valid measure. Reliability means that the measurement procedure produces consistent results over repeated applications. The best illustration, the best simple illustration I know of to use as an example of both validity and reliability is the bathroom scale. Everyone's familiar with a bathroom scale. As we all know, there are different qualities of bathroom scales. Let's say you have a subject, a person, who weighs 200 pounds. If that person gets on the scale and it indicates 200 pounds, you're pretty confident that your scale is measuring that person's weight. Well, how do we know originally that the person weighs 200 pounds? One of the ways, and as we'll be discussing later when we talk about demonstrating or testing or proving the validity of a particular measure, is that we have another measure of the underlying thing. So, for example, if we had a true and trusted scale, say at a doctor's office or something that had been validated, we knew it, and we wanted to test our particular bathroom scale to determine if it was valid, we would first have the person step on the doctor's scale, step off, and then step on our bathroom scale and see if they gave the same result. It's one method of validating a new measure or a different measure. Why would we want to do that? Well, obviously we can't always run to the doctor when we want to know how much we weigh. So we have a scale, a less expensive, more convenient measure in our own home. And this is often what we want to do. Some concepts, we are very confident of certain ways of measuring them, but those particular measurement procedures are very expensive, or very time-consuming, not very convenient, very cumbersome. So we develop a new way to measure that same concept that is more convenient, cheaper, easier to administer, what have you. And then we have to validate it. And in fact, one of the ways we validate it is by testing that on a small group to make sure our new measure gets the same or very similar results to the old measure. What about reliability? Well, again, using the bathroom scale example. If you step on your bathroom scale and it says 200 pounds and you step off, you step back on and it says 200 pounds, you step off, you step on, step on, step off, over and over again, and it says 200 pounds every time, you have a reliable scale. So reliability is about consistent results over repeated applications. Now notice, you have to do this immediately when we're talking about the bathroom scale example. If I step off my scale and go and eat a chocolate shake and then step back on and it gives me a different result, that does not mean that my scale is not reliable. It means that the underlying thing I've measured has changed. So that's one of the difficulties in validating the reliability of a particular scale or of a particular measure. If I ask you a question about an attitude, I cannot immediately ask you that same question to see if it's reliable. Your second response will be shaped by your first response. You will remember it. We cannot reach into people's minds and erase their memory of being asked this question and then ask it again. So confirming the reliability of many of the measures that we use for evaluation research is a much more difficult thing than confirming the reliability of a bathroom scale. Which of these two things is worse, invalidity or unreliability? Well, think about it. It really depends on the context. If you have an unreliable scale, an unreliable measure, a measure that gives you slightly different results every time, but on average they give you a good result, that's not too bad if you know about the unreliability. In fact, almost every measure out there has some degree of unreliability. Even very sophisticated medical measurements, of a person's temperature or blood pressure or what have you, have unreliability in them. That does not make them a bad measure. It simply means you have to be aware of it. What about validity? Well, validity comes in different ways and shapes and forms. If your measure is not really measuring at all the underlying thing, if it's totally invalid, obviously that's a serious problem. If you use a tape measure to measure a person's weight, for example. But if I've gone to the doctor's office and measured myself to weigh 200 pounds, and I come home and step on my bathroom scale, and it gives me 205 pounds, and it does that consistently every time, thus it's reliable, well, we have a biased measure, but we know about the degree of bias. Again, biased measures may or may not be a problem. It depends if we can detect and know the bias. Some things constantly have a measurement error in the same direction of approximately the same degree. And if that's a known problem, it can be very easily fixed. And in fact, it's less of a problem than an unreliable measure is. So these things are not absolutes. They are they're relative to each other, and they're relative to the research design and what you are trying to do. Of course, the ultimately reliable and valid measure, as I mentioned earlier, is often very expensive or very difficult to do. Imagine, again, using some of the examples I've been using throughout the class, a program to eliminate prejudice, or drug treatment programs, or what have you. You can think about ways to measure the underlying idea, a student's skills at performing mathematical operations, a drug addict's ability to resist the urge to do drugs, what have you. We can think about some very sophisticated and complicated and expensive ways to measure those things, but those are often not really feasible in the area of evaluation, so we have to come up with cheaper, easier to administer methods of measuring those things. All right, another topic related to measurement, the idea of levels of measurement. A key part of this translation process that we're going through when we're measuring a construct is working with the measurement properties of the variables that we're developing. Remember, we've got two things here. We've got constructs that are more or less not directly observable, and then we have the variables that result from our measurement procedures that are directly observable. So we're translating the construct into a measure, the construct into a variable. A key part of that is understanding the mathematical properties of different variables. What we want to do is try to make sure that the mathematical properties of our variables reflect the underlying mathematical properties of a concept or of a construct. This is referred to as a level of measurement. What do I mean by mathematical properties? Think for a moment about a concept such as sex. A person's sex has two categories, typically when we're dealing with it, male and female. That's a pretty easy one to measure. Think about the two categories, male and female. What kind of mathematical properties do they have? Well, the only mathematical properties the two categories would have would be that, first off, they're different from each other, and secondly, that under ordinary circumstances, every case we look at, every observation we make will fit in one and only one category. We refer to these two things as being mutually exclusive and exhaustive. Mutually exclusive means that the categories do not overlap. Male and female do not overlap. If we have exhaustive categories, this means that every case has a spot. There is a spot for every observation, a category of the variable for every observation. So, for example, let's say another example of a nominal level of measurement might be a person's religious affiliation. Now, we can measure that in a lot of different ways. We could talk about them being Christian, Islamic, Buddhist, what have you. Or none would be a final category, because some people do not have a religious affiliation. So we need to make sure that our categories did not overlap, they were mutually exclusive, and that they were exhaustive. So we couldn't just list different major categories of religion. We would have to make sure that we included a category for none, and maybe some other interesting little categories in there. Agnostic might be a category. But again, so those categories have no other mathematical relationship. We cannot, for example, rank order these categories. And notice we can have different levels of detail, different levels of specificity. Within Christianity, there are literally hundreds of different types of religious affiliations. Obviously, we've got different sorts of Baptists, different sorts of Lutherans, Catholics, lots of different kinds of details there. So one of the questions we would have to consider when we're creating our measure is what level of specificity, what level of detail do we need? But that's true about any measure. If I'm measuring a person's weight, I may not need to measure it to the ounce, probably to the pound, maybe even to the nearest 5 pounds. Income, I may not need to measure it to the dollar. I certainly don't need to measure it to the penny. Maybe to the nearest thousands of dollars would be close enough. But that's another issue. That's the issue of specificity. All right, so nominal level measures are, the categories of them are mutually exclusive and exhaustive. I've given you a few examples, things like race, sex, religious affiliation. The categories are just names. Ordinal level measures. Ordinal level measures have both of those characteristics. The categories are mutually exclusive and exhaustive, but a new idea, a new mathematical property has been added. For an ordinal level measure, the categories can be ranked. The categories can be ranked. So, for example, we might have a question on a survey questionnaire to which the response categories are strongly agree, neutral, disagree, and strongly disagree. We can rank order those categories. There's a natural, obvious order to the categories. We might measure age at the ordinal level. by classifying people as young, middle-aged, or old. Interval and ratio level measures. These are actually two different levels of measurement. They are typically included in this discussion, both of them. But a word to the wise here. There are very few interval level measures out there in the world that we would typically deal with. But the idea of having an interval is an interesting and separate mathematical property, logically speaking, from what a ratio level measurement is. So interval and ratio level measures have the same properties, as the two lower levels. So again, all of the categories are mutually exclusive and exhaustive. The categories can be ranked. But now we have, first off, a known distance between the categories, a known interval. The best example, the most familiar example of an interval level variable that everyone knows about is temperature. Whether or not you're measuring it as Fahrenheit or Celsius or centigrade, temperature is an interval level measure. The distance between 50 degrees and 60 degrees is the same as the distance between 60 degrees and 70 degrees. What separates interval and ratio levels of measurement from each other is the idea of a true zero point. Neither the Fahrenheit nor the Celsius scale of temperature measurement has a true zero point. Now there is a measure of temperature, to get way off of the subject of social sciences, there is a measure of temperature that does have a true zero point, known as the Kelvin scale. But here, think about this. Thinking about Fahrenheit temperature or a Celsius temperature, we cannot say that 40 degrees is twice as warm as 20 degrees. We know it's higher, we know how much higher it is, but we cannot talk about twice as much in the way that we can if we have a true zero point. Think about money, for example. A person's income. $20 is twice as much as $10 because we have a zero point. What makes talking about those kinds of ratios, twice as much, half as much, is having a zero point. So that's what sets apart a ratio and interval level of measure. And as I said, most of the measures that we have that go beyond ordinal level of measurement do reach this ratio level in the social sciences anyway. Alright, so these levels of measurement can be viewed as four sets, or really three sets, each one being nested into the next highest level, with nominal measures being the lowest, ratio level measures being the highest. The reason we have to know about these things is we want our variable, as I said first, to map onto the underlying construct. If the categories of the construct that we deal with in the real but hard to measure, hard to put our finger on world, are not only names, like race or gender, then we want our measured variable to reflect that. The problem is that many constructs can be measured at more than one level. Not only can they be measured in more than one way, but they can be measured at more than one level. Look with me, for example, figure 4.4-2 here. Different levels, same construct. So think about education. We could measure a person's level of education in an ordinal fashion. We could have a survey in which they checked a box. Less than high school graduate, some college, or college graduate. These categories are certainly separate from each other, and they are rank orderable. We know that the college graduate has the most, the person with a less than high school degree has the least, and these others fall in the middle. We know the order. Or we can measure education as a ratio level measure. Ask a person how many years of formal education they have. Response categories here would be none, 1 year, 2 years, 3 years, 4 years, 5 years, 6 years, etc. So, we can measure concepts at different levels, not just in different ways, but at different levels. This becomes very important later on when we consider what we want to do with the data. The math that you can perform differs. We talked about in the previous chapter statistical validity, and later on in Political Science 6003, the research techniques class, we'll talk in great detail about this. But for now, just think about this. If I measured education ordinally, it would be impossible for me to add up people's scores divide by the number of people, and come up with a mean, come up with an average. If I measure it at the ratio level, I can add up the number of years of education of each of my observations, divide by my number of observations, and come up with a measure of the average or mean level of education. Now, we've got a final idea to talk about here in this first lecture, and that is the idea of units of analysis. Units of analysis refers to the objects or entities about which we are trying to draw conclusions. I've listed here a few of the kinds of units of analysis that social scientists and evaluators typically have to deal with. We might be trying to draw conclusions about individual people, about organizations, about cities, about clients, or even about groups of things like families or dyads, like a mother and child pairing, what have you. We are measuring the attributes that are of interest of these things in order to draw conclusions about these things. Now, usually, but not always, units of analysis are the same as the unit of observation, the object we are measuring. Okay, usually, but not always. We might, for example, collect data about individual students when we're actually interested in comparing schools or classes at a school. So we observe students, but we aggregate that data in order to draw conclusions that allow us to compare different classes at a school, or to compare different schools, or maybe to compare different state school systems, one to the next. It's almost always possible to aggregate data in that fashion. The problem is when we go the other way. If we collect data about schools, we cannot always make inferences about individuals. For example, let's say I had collected data. I'm evaluating a program of instruction, and I've implemented the program at a number of different schools. Some schools are predominantly, let's say, urban schools, and others are rural schools. If all I've done is collect data about average test scores or what have you, so aggregate level data about a bunch of different schools, I cannot go back and say, well, rural students tend to be this way, and urban students tend to be this way. Because not everybody who goes to a predominantly rural school is from a rural background. Not everybody who goes to a predominantly urban school is from an urban background. If I have a predominantly black school and a predominantly white school, and I've collected data at the level of the schools, I cannot make inferences, I cannot draw conclusions, I cannot switch units of analysis to individuals. I can't make differentiations about race or what have you. Okay? So you need to be aware of this. Again, as I say, usually but not always these two are the same things, and it's much easier to go to aggregate data, to go from a sort of smaller unit that we can later group together, than it is to go from a larger unit and try to disaggregate. So one must carefully consider in doing the research design and designing one's measures what it is we're trying to draw conclusions about. Are we trying to draw conclusions about individual people, for example, or about aggregates of people, different schools? You have reached the end of Lecture 4-1, Measurement and Program Evaluation. Please be aware that Lecture 4-2 and 4-3 are PowerPoint presentations only without any sound. The concepts discussed in those two lectures, 4-2 and 4-3, I feel are very straightforward. Plus, by this point in the course, you may be a little tired of listening to my voice. So those slideshows, those PowerPoints, are there for you in an attempt to let you kind of extract your own meaning from them, because I think it's pretty easy to do. So with that said, I ask you to proceed to Lecture 4-2.